Lesson 8-3, Stem and Leaf Plots. So data in stem and leaf plots is organized from least to greatest. The digits of the least place value usually form the leaves, and then the next place value forms the stems. So when we are creating stem and leaf plots, you want to kind of follow 3 steps. Step 1 is you choose the stems using the tens digit. That's what's going to create your stems. That's going to create your numbers. Step 2, you list the stems from least to greatest. Then you write the leaves in the ones digit to the right of the corresponding stem. So if you had like the number 15, you would put the 1 in the stem and the 5 would be the leaf. And then you order the leaves and write a key that explains how to read the stem and leaves. Make sure to always include a title with every graph you make. Let's look at this example together. We have the number of minutes the students in Mr. Mullins' class spent doing their homework one night is shown. Display the data in a stem and leaf plot. So we first want to list these numbers from least to greatest. So we have 0 and 5. So you want to make sure you cross out the numbers that you've already used so you don't reuse them. Then we have a 23, a 24, a 30, another 30. You want to make sure you write a number down even if it repeats because you're still going to include that number in your table. You have a 35, 39, 42, 45 is used twice, 3 times actually. 1, 2, and 3. 47, 49, 51, 55, 56, 58, and 2 75s. Now you're going to use your tens digit to create the stem and the ones digit to create the leaf. And that's even going to happen when you have a number like 0 and 5. For your ones digit, it's just going to be a 0. For your 0, but for the tens digit, you would replace a 0. You still want to have that place value. So the tens digit for your 5 would also be a 0. So you would almost want to imagine these as 00 or 05. So to create our stem and leaf using our numbers, we have the 0 and the 05. So here's the 0, and then that would be the 5 and the 0 in front. So then we have the number 1, 2, 3, 4, 5, 6, and 7. Then you must add your leaves that correspond. So we did not have any numbers that started with the ones digit, so we just leave that one blank. But we did have 2 numbers that started with a 2. We had a 23 and a 24. And then we had a 30, we had another 30, we had a 35, and a 39. So the 3 is the tens digit, and the 0, the 5, and the 9 would be the ones digit. So then we had a 42, a 45, another 45, another 45, a 47, and a 49. We had a 51, a 55, a 56, a 58. We did not have any 60s, and we had a 75 and a 75. Now when you create your key, you basically just want to show what is this representing. So we would be able to take the first set of numbers here, the 2 and the 3, and we can say that this represents 23 minutes. So that would be your key, just kind of demonstrating that the stem is the tens and the leaf is the ones, you can do that just with your key. And then you want to title it. So you may title it minutes of homework. Just something very quick so that those that are using or seeing the stem and leaf plot know what they're looking at. Now, with stem and leaf plots, we tend to have a lot of outliers. Outliers are numbers that typically stand out from the data. Kind of think of them, if you hear of an outcast or an outlier, they're usually someone that doesn't agree or doesn't get on or doesn't really fit in with the normal crowd or the normal set of data. So you want to evaluate the effects that the outliers have on each central tendency. So by doing that, you want to calculate the mean of the data and the median without each outlier. Then you want to calculate the mean and the median with them and compare those two. If the mean and the median go up, then you would say that the outlier will increase the data. If the mean and the median go down, you would say that the outlier would decrease the data. If there's no effects, then you would just say the outlier did not cause any effects on the data. So let's take a look at the effects of adding 90 minutes to the time for Mr. Mullins' homework time. So if one of the students said that it took them 90 minutes, this would have been considered an outlier because it did not really fall in with the rest of the data and it's kind of drastically out by itself. So when we find the average of the data without the outlier, we get 832 over 20, which is approximately 41.6. The median without the outlier, so without it, is 45. If we add the outlier, so with the outlier, the mean becomes 922 over 21, which is approximately 43.9, but the median is still 45. So the effects of the outlier here would be that the outlier causes the mean to increase, but there is no effects on the median. So the median has no effects. So you could just say none. There will not be a lesson review for this video. Just make sure you try some examples. You're identifying your ones digit, the title, your key, and the effects in which outliers can have on the stem and leaf plot.